For 2 decades, a single particle teased physicists with a hint that our entire understanding of reality was incomplete, that a fifth fundamental force might be hiding in plain sight. Whole careers chased it. And in 2026, the answer arrived. It wasn't the answer anyone expected, because it turned one mystery into a stranger one. This is the story of the muon. Everything in the universe is governed by 4 fundamental forces: gravity, electromagnetism, and the 2 nuclear forces. Our best theory, the Standard Model, describes them with absurd precision. But physicists have always suspected it's incomplete, so they hunt for cracks, places where reality and theory disagree even slightly. The muon offered the most tantalizing crack in a generation. A muon is like an electron, but about 200 times heavier, and it acts like a tiny spinning magnet. Put it in a magnetic field and it wobbles like a top. The Standard Model predicts exactly how fast, but that wobble is also nudged by a swarm of virtual particles flickering in and out of existence around it. If unknown particles or a new force existed, they'd nudge it too, and the wobble would come out slightly off prediction. Starting at Brookhaven National Lab and then confirmed in a beautiful experiment at Fermilab, the measured wobble came out persistently larger than predicted. The gap was tiny, but it held up across years of data, eventually reaching a statistical strength that, in physics, usually means this is real. Excitement built. This might be the doorway to new physics. Then came the twist. The weak link was never the experiment, it was the prediction. Calculating the muon's expected wobble means accounting for the strong nuclear force, which is fiendishly hard to compute. The original prediction used one method drawn from other experiments. But a newer approach, Lattice QCD, run on supercomputers, calculating from first principles, produced a higher predicted value, one that lands much closer to the measurements. If Lattice QCD is right, the anomaly mostly vanishes. No new force. The Standard Model holds. But here's why physicists aren't celebrating a clean ending. The 2 ways of predicting the muon's wobble, the older data-driven method and the newer Lattice QCD, now disagree with each other. Both are built by serious people using serious tools. One says there's an anomaly, one says there isn't. So the mystery didn't close, it moved. Instead of, is there a fifth force? The question became, why do our 2 best calculations of the strong force disagree? That's arguably deeper. It's tempting to feel let down. 20 years, and maybe no new force. But this is how science actually works. Ruling out new physics with this precision is itself a monumental result, and exposing a disagreement between 2 trusted theoretical methods points researchers at something real they didn't know they misunderstood. The muon didn't give us a new force, it gave us a better, sharper question, and in physics, that's often worth more. The hunt for a fifth force may end not with a discovery, but with a humbling lesson in how hard it is to predict reality precisely. The muon kept it secret and handed us a new one. Science Untold, where even the dead ends are doorways,